There is a code written under the heading of Earthquake Design Codes for RCC Structures. Now this code actually, which is called as Building Code of Pakistan, is primarily used as the main design codes for all structures in the Pakistan, right? Now on the screen you can see there is a white display page which is called as the title page of BCPSP07. Now the BCPSP07 stands for Building Code of Pakistan Seismic Provision for year 2007. Why this year is mentioned here? Because this code was first generated for practical implementation in year 2007, right? So since 2007 this code is in order, and we are using it for designing various types of structures based on the seismic design codes, right? Now this seismic design code is carrying 2 or 3 volumes or revisions, I would say, and in today's designing, in the latest version is being used. Anyhow, the basics are same. So whether you study seismic design codes volume 1 or volume 2 or volume 3, these are almost similar with slight modifications. Now the origin, or the, I would say, the theme of this code has been taken from another building code which was used initially for seismic design, that was called as UBC, or Uniform Building Code. So the UBC 97 or Uniform Building Code volume 2 is the guideline for creating these seismic design codes for all structures to be designed in Pakistan. Why I am mentioning the country? Because every country should have its own seismic design code. Some of the countries are having it, some are not having it. For example, in our native country India, there is another code which is being used only for designing structures in India. There is another code which is used for designing the structures in Japan, something like this. American codes are used mostly in those countries that don't have their design codes. So Pakistan is having luckily a design code available for designing various types of structures, keeping in view the earthquake designing, right? So today we are actually discussing not the general building codes, we are discussing the seismic design codes. Now based on this discussion, what is the procedure for designing the structures based on this code? In this code, which is known as BCPSP07, the basics are taken all from UBC 97, as I said earlier. And in UBC 97, the method to calculate the seismic forces for various structures is known as lateral force determination procedure. So there is a pattern which contains number of steps, and these steps are basically part of UBC 97 seismic design calculation. These steps are also copied directly, taken directly from UBC 97 and incorporated in BCPSP07, and we have to follow the same procedure of calculation of lateral force for designing the structures due to earthquake forces. Now the question is why this UBC 97 has been selected. There are a number of codes available in all around the world, so we can use any of the codes to design our structures for earthquake. But the UBC 97 was found to be more relevant and more appropriate for our environment. The safety factors, the reduction coefficients, the load increasing coefficients that were suggested in these codes are quite applicable in our country. So that's why the natant, or I would say the parent code, or the guideline for seismic designing in Pakistan has been taken from UBC 97. Therefore in BCPSP07 we will follow the same procedure as written in UBC 97. Why I am explaining it? Because in the coming slides we'll discuss and we'll see all this procedure and steps and all the parameters which are required to design to calculate the earthquake forces. Now in seismic design of RCC structures, the UBC has given us 2 lateral force determination procedures. One is called dynamic lateral force procedure, other is called static lateral force procedure. This is mentioned in UBC section 5.31 and 5.3.2, right? So we'll study these procedures one by one. and we will inshallah make it easy for designing the earthquake structures. Now the question is that when we design the earthquake structures, or when we design the structures for earthquake forces, the main thing is that you should understand what part of the code is supposed to be used. Now here in this slide you can see a empirical formula that is suggested in the codes, and this formula is actually giving us the basic or the total base shear in each or any structure that is being designed for earthquake. What is base shear? Base shear is the total lateral force. You see here is the word lateral force mentioned here. The base shear is the total lateral force that can be generated, the maximum lateral force that can be generated during an earthquake at a position or at a zone in any structure. So this base shear or lateral force is dependent on so many factors or so many parameters. So if you cannot calculate all these parameters, or if we are not able to select these parameters from the codes, we are not able to calculate the actual value of base shear, Therefore, for base shear calculation, it is very important that you should understand the right side of this empirical formula, which contains 5 basic parameters, which needs to be either selected from the codes or that needs to be calculated manually based on the type of structures. These parameters are dependent on the type of structures as well. Now we will explain, or we will discuss these parameters one by one, because these are very important and you will be using it throughout your life, whether you are calculating the base shear or lateral force manually, or you are using a software to calculate this base shear. In both cases, you will be looking, or you will be in need of calculating these parameter values to put it in the software, or to do it manually, something like this. Now how to work on it? You see on the left side we have got capital V, which is called as design base shear of a structure that needs to be designed for earthquake. Now this design base shear is called the total lateral force, right? And in this formula, this lateral force is representing the static lateral force. It means that this procedure, or this empirical formula, is representing the part 2 of the lateral force determination procedure of UBC 97, which is being given in detail in section 5.3.2, right, of BCP SP07, and it is also given in chapter section 1630.2 in UBC 97. But in nowadays we are not looking at UBC 97, we are mostly studying these BCP SP07 codes. And if you come out to chapter number 5 and article number 30.2, we will be getting this formula and all the relevant information about this empirical formula. So I am explaining this formula to you. On the left side we have got total earthquake force, which is not mentioned as earthquake force, it is mentioned as design base shear. So whenever this word design base shear comes, it is representing the total earthquake force developed in a structure at the time of earthquake, right? In shortcut it is called design base shear, or simply base shear. On the right side we have got 5 parameters, such that there are 4 parameters which are enclosed in a bracket, and there is 1 parameter which is written outside. Now the parameters which are enclosed in a bracket needs to be selected from the codes. You cannot calculate these 4 parameters, CV, capital I, capital R, capital T. These needs to be selected from specific part of the codes, like BCP SP07. You will be using these codes, and after using these codes you will be writing or selecting the values of these parameters based on the type of structure, based on the type of seismic zoning, and also based on the height of the structure, the geometrical figures, all these things. This will decide which value needs to be selected from codes to be used in this equation. While this value of capital W, which has been written outside the bracket, this needs to be calculated. You cannot select it from the codes. So once it is calculated, it needs to be placed here for calculating, for finding out total V. But this W is calculated on a very specific mode, and it is you need to be very much careful while calculating the capital W value for a structure, because this varies from type of structure. For steel structures it will be different from RCC. Low-rise structures it will be different for RCC. Structures containing too many partition walls like apartment buildings, something like this, the value of W will be totally changed. For RCC structures like flyovers, underpasses, this value will be calculated in a different way. So therefore there is a different procedure to calculate the value of W. We will discuss it here as well at a glance. Now to start up with the discussion on the parameters, you have got CV, capital C small v, right? This is called as seismic coefficient. You can see here seismic coefficient. This parameter is totally dependent not on the type of structure or on the height of structure. It is totally dependent on the seismic zone where the structure is lying. You see, I explained that thing in the previous lecture, that the seismic zoning is playing an important role to decide the structure will fail or it will not fail. And there are various radial dimensions which guide us to define or determine the position of the structure based on the seismic zone. So if you remember the previous lecture, we were studying the 50 kilometer radius, we were discussing the 100 kilometer radius, we were discussing greater than 100 kilometer radius of focus point or epicenter from the structure or something like this. If you remember the previous lecture, you will be actually able to understand it quite easily. So if we based the CV on the type of seismic zoning, in Pakistan there are 5 seismic zones, or 5 major seismic zones, which are known by the word seismic zone 1, 2A, 2B, 3 and 4. And if you remember, I told you that the 4th seismic zone is called as the red zone because it is normally happening, or it is present near to the fault line within 50 kilometer radius, maybe from the focus point or epicenter. So based on that, the CV value is taken from the BCP SP07 chapter seismic zones coefficients. So there is a table which is used to fix the value of CV for a particular structure. That table is called table 16-R of CVBDC 97, and the same name is given to it in the BCP SP07 course. Table 16-R will give you the accurate value of CV based on the location of the structure, right, where the parent guideline will be the seismic zoning location. So you cannot calculate the CV, you have to select it. Now there are 2 values of CVs. We will include the detailed codes, tables and all this stuff somewhere in the future lecture, but the value of CV is also linked with another value which is known as CA. CV and CA are both seismic coefficients, such that CV is the higher range of seismic coefficient and CA is the smaller range of seismic coefficient, right? So when we select the value of CV from a table, there is a column in the table 16R which gives you a value of CA, capital C small a. So you will select the CA value which is linked with the CV. So we will select actually a pair of coefficient, 2 values of a coefficient, and those coefficients will be called as seismic coefficients. So if you wrongly select the value of C, right, if you wrongly select this value, it means you have not located the structure properly at the position where your structure will be constructed practically. So it is very important to find the accurate value of CV from the codes and its relevant pair value of CA from the codes, so that you can calculate the actual value of earthquake force known as design base shear. So when you select the value of CV from a table in the codes based on the seismic zones, now how to get the value of CV? For example, in the table there is a value of CV for seismic zone 1. There is another value of CV for seismic zone 2A, for seismic zone 2B, 3, 4. So if you come to the seismic design map of Pakistan, if you remember it, we have included it in the previous lecture. There was seismic map of Pakistan which was shown with different colors, yellow color, green shaded color, blue shaded color. If you remember that, there was a red shaded color which was representing the red zone or zone 4. So if your city is lying, if the structure is lying in a city which is in seismic zone 3. So you will only focus in getting the value of CV which is been selected or calculated for zone 3. You cannot use the value of CV for which can be used for Peshawar. And if the structure is constructed, for example, in Chitral, in Swat, so you cannot use the value of CV of Peshawar for Swat and Chitral region. So that structure needs to be modified for the revised value of CV which has been fixed for zone 4 or zone 3. So that your zone 3, for example, the Swat city or the city of Swat is actually lying in zone 3 and city of Chitral is lying in zone 4. So these districts need to be properly evaluated. So it means that the table will be used in coordination with the seismic design map of Pakistan, and from these two documents you will fix the value of CV for a particular structure. Now talking about the value of capital I. What is the value of capital I? It is known as seismic importance factor. This value actually represents the type of structure that is being designed for earthquake. Let me quote an example for you to understand this parameter. If you are given a task to design 3 structures in Peshawar, one is a residence, second one is basically a market, and third one is a hospital building, right? So based on the use of the structure, I would rate these structures as 1 to 3. I'll give the highest rate to that structure which is being used by a greater number of people. So based on this parameter, the 3 structures like hospital, a market and a residence, the most important structure for me will be the hospital, because it is used on random basis by hundreds of residents each day, right? So for seismic importance, the greater importance is given to that structure which is being used by a greater number of people at a single day. So for me, the hospital is more important, followed by the market, and then followed by the residence, because a residential building or a house is used only by the occupants which are the owners of that house. Those are the owners. Like there may be 4 or 5 people in each house, right? So for that reason, the residence is used only by a few number of people, while a market is used by a greater number of people. But the hospital is much important because it can be used by far greater number of people. So based on that thing, the value of I is selected, and there is a table present in the codes. That table gives you the guideline which value of I needs to be taken for a structure that we are designing for earthquake, right? So first we have to fix the value of I based on the type of structure, right? So there are various categories written in the table, category 1, 2, 3, 4, 5. So the more important structure, the greater category will be given, and based on that the value of I will be selected from the relevant table. We'll discuss it somehow when I'll present you these tables, and we'll explain this. We'll discuss these tables one by one in the later lectures. Right now, when you calculate or select the parameters which are given in the numerator, then you have to select the parameters which are given in the denominators. So there are 2 parameters in the numerator and 2 in the denominator, and the 4 parameters and are then closed in a bracket. So the denominators contain 2 parameters, in which the first one is very important for designers. It is called response modification factor in shortcut, but this capital R is in detail is explained as numerical coefficient representative of inherent overstrength and global ductility capacity of lateral force resisting systems. So there is a detailed name given to this capital R, but in shortcut it is normally known as a response modification factor. What this R actually represents? This R actually overall determines the performance of a structure against the earthquake force. I would repeat again, this R actually determines how well a structure will respond to an earthquake at the time of earthquake. So if you have well designed a structure based on the seismic zone, you will get a very good response of the structure at the time of earthquake. But if the structure, its components like location of beams, location of columns, the grid spacing, the size, the dimensioning of the structural members, and all these things, if these are not properly designed based on the CV and I value, you will not get a good response from the structure when there is an earthquake. So this is what is called R, and in shortcut it is called response modification factor. Now the question is how this R value is selected. There is a table given in the course again, and this table actually gives you the guideline which type of or which value of R needs to be selected. Now this table contains various values of R starting from 2.5 and ending at 8.5. I would repeat, the values of response modification factor starts from 2.5 and finishes at 8.5. In between there are various other values like 4.5, 5.5, something like this. Now the question is which value is more relevant to a structure. All the residences like your houses, which are basically load bearing structures, load bearing wall structures, there are masonry walls which are taking the load and there is no framing in a residence, right? In nowadays we are introducing framing elements in a structure of a residence to improve its value of R, but in previous residential buildings you will not get any framing of the structure in the residential buildings. So only the load bearing walls or the masonry walls will take the whole lateral force of earthquake. When we use the word lateral force, it means it will not be in the direction of the brickwork or wall. Like if the slab is resting on the brick wall, okay, it is called vertical loading, but this lateral load is not vertical load, it is horizontal load actually. It will come from the side. Now if you consider a brick wall, let me explain this value of R for you, then it will be easy for you to select the value from the table. In a brick wall, there are hundreds and thousands of bricks, right? And we join these bricks through mortar and in the form of courses, right? So there are courses of bricks, and after placing course over the course over the course, we'll get a height of the wall. Now these courses are actually the units which contain number of bricks arranged in line, but these are not one element, these are different elements, like the different number of bricks which are binded together through mortar. So based on that, if you put a lateral force on this brickwork, it will not be able to withhold this lateral or horizontal force, because it can only take the load which is coming in vertical direction, like the load of the slab on the wall. So based on that concept, the brickwork or the brick walls are normally called as roller support. If you remember the type of support that we've studied in your structural courses like structure 1, structure 2, there are 3 types of supports that you normally study, like roller support, hinge support, fixed supports. So technically or practically there are no roller supports, there are no hinge supports. The supports are the behavior of the supports is like roller or it's like hinge, right? So you will not see a wheel somewhere which is placed below the structure to call it as a roller support. Roller support is not a wheel or something like a roll, right? It is a solid structural support, and the practical example is brick wall. But the problem with brick wall is that it can only resist the vertical load. For example, in roller support, if you put a beam on the vertical on a roller support, you will only get the resistance in one direction, right? This is called roller support. Same is the case with brick wall. You will get the resistance only in the vertical direction of the wall. So if there is a horizontal force applied on the wall will collapse. The courses will separate itself from each other. The bricks in the courses will separate itself. There will be cracks in the joints. So whenever you experience an earthquake, you will always see some cracks in the wall. There can be vertical cracks, there can be diagonal cracks, there can be horizontal cracks. Why these cracks are developing in walls? Because the walls are the roller supports. The walls are not made to take the horizontal load. walls can never take the earthquake load. So based on that discussion, I would give the minimum value of R for those structures which are resting on walls, like your houses. Practically the value of R for houses is only 1. It is not even 2.5, although the table which is used to select the value of R starts with the value of 2.5, but I will practically give the value of R is equal to 1 for your houses, which means that houses are poor structures. These are undesigned structures because your houses are resting on roller supports. These are roller supports which are not allowed in engineering, especially when you use the word earthquake. So how to cater this thing? You will be constructing the houses definitely. You will have to improve the value of R. You will have to convert this roller support into hinge support. How can you do that? Improve the stiffness of walls. Improve its thickness, number 1. Improve the joint conditions, number 2. Improve the corners of walls by introducing vertical confinement elements. Introduce the binding elements like plinth beam, lintel bound beam, slab beam, something like this. So there are various measures which are applied in the design of residential buildings in nowadays when you are designing it for earthquake. Now question is, if a residence is lying in the no seismic zone or the minor seismic zone, known as seismic zone 1 in Pakistan, then for Pakistan, for seismic zone 1, the residential buildings do not need to be designed for earthquake, because for zone 1 there will be no major base shear force developed. There will be no development of base shear force. But for seismic zone 2A, 2B, 3, 4, their buildings like residences need to be improved in performance against the earthquake. You need to create this lateral force resistance in the residential building supports. And how can you do this? Convert the walls like roller supports into hinge support. A wall can behave like a roller support, and the same brick or masonry wall can behave like a hinge support. At least you convert this roller support to hinge support by modifying the brickwork and conditions, by applying the joints, stiffeners, by improving the thickness of important masonry walls, by introducing cross wall concept, introducing buttresses, introducing bond beams. All these measures actually result in converting the roller support into hinge support. And then you can say that R is improved, and you can take the value of R from 2.5 to 3. हाँ जी, मासूमा improve को R value from 2.5 to 3. Start शवेसन हो एक ना सासो कुरुन नदे टाइम के एक R value लगी. एक means nothing. It means that that was the equation that हो रही है. I'll expend my whole time on this equation, which is very important. We are practically using this equation in nowadays to calculate the earthquake design force resistance in a structure, right? Now, go to the equation के the W हो आखिर के मुंह में discuss करूँगा. In the bracket, we have got 2 parameters in numerator and 2 parameters in denominator. Nosta the V chikam de, which is basically the total earthquake force developed in a structure at the time of earthquake. Shortcut के मुंह में base shear. Nosta so the base shear chikam de या earthquake force chikam de यो structure के बजोड़ी की नहा सशेषर बज़ियाती की और सशेषर बकमी की होगा. जब denominator value ज़्यादा की automatically इंस्टा सो base shear value ज़्यादा की. It means इंस्टा सो CV value का ज़्यादा इंस्टा सो V value का ज़्यादा. Directly proportional लेगा ना. These are directly proportional nominators. इंस्टा सो high seismic zone के CV value का ज़्यादा. नो है कि definitely earthquake force बा ज़्यादा जोड़ी की. Common sense दे. But in the denominator, there are 2 values which are not related to the seismic zone. These are related to the type of structure, the performance of structure, the strength of structure, which is basically the objective of the designer. This is how a designer is called a designer. He has to design such a structure which will give you the maximum possible value of R and T. This is what R value, T value zyati. Starts with the denominator, the wajana starts with the denominator performance, but it comes the value become shigana, right? The R denominator is zyati starts with the CV by R chikamne the bata ke digana. Starts with the C value become partish. Ya indirect value issue. Just starts with V indirectly proportional to R. It is directly proportional to CV and I, and it is indirectly proportional to R and T. So if the value of R is greater, your V will be decreased. Your V will be decreased. मतलब कम टाइम के लगाना जी यार क्लास ऐसे गप लराश the value of R will be greater. This will result in decreasing the value of earthquake force. So if your even structure is lying in seismic zone 4, so seismic zone 4 को CV by highest है ना, CV highest है, so V by highest है, for the V highest then do. How can we do this? Improve the value of R to maximum. हाँ जी, उस जो structure ले आया कि R value कम दे, which is R is basically what? The performance of structure, right? Like that's the simple example code के चमूं roller support by hinge तक convert को performance by खशी गया. दार your frame structure दे आया कि सासो frame structure half structure ही चाहिए कि celery celeru beams लरू और columns लरू, right? We are having frames in this structure. The frame structure के कैसा सो your frame structure less columns लरू. Columns means the vertical elements like of resistors. और your bulk structure बस रखवा के जोड़ दे it contains 20 columns. So which structure will perform better? The structure with 10 columns or the structure with 20 columns? Definitely the structure with 20 columns. Now this is so R by improve shigan. Now they were the R value chikam de 2.5 no chati 3, 4, 4.5, 5, 5.5, 6, 6 maximum 8.5 full resi. Now your structure ke R value 2 e or your bulk structure ke R value 8.5 e, which will be safer? Definitely the value with R is equal to 8.5 will give you much safer structure against the earthquake force. Now basically earthquake force हमेशा पर न मौजूद नहीं आपको, it will be there only for a few seconds, right? Say 10-20 seconds, something like this, less than 10 seconds. For this few seconds can cause the destruction, the complete failure of the structure if you have not dealt with the R, right? Now that is important parameter the earthquake designing के चार किस्म स्ट्रक्चर है का कोरी का प्लाजा का हॉस्पिटल का फ्लाईओवर दे का अंडरपासेस दे का हाइड्रोलिक स्ट्रक्चर दे वेयर दे बैराज दे डैम दे दिस आर वैल्यू इज प्लेइंग द मेजर रोल टू improve the performance of structure against the earthquake. They were the more response modification factor, right? Haji, the Varsala Saloram Chikam parameter that is called time period of vibration. Sashiri, time period of vibration. That basically dependent on R. The team explain what is called time period of vibration. The depend. Number one, height of the structure. Height. Your building the less chata. Your bulk building chicken pinza chata. Your dream building or pass shell chata. Right? So with a 20-story building and with a 10-story building, with a 5-story building, if we apply the lateral force or the earthquake force at the time of earthquakes, the 20-story building will be more difficult to handle because I saso da vibration chikam de usual je shuru shida be bandi gina de muqabla ki 2 या 3-story building chikam de da bazar vibrate shu zar like I vibration ma khatam shi. So the natural time period of vibration depends number one on the height factor, right? Therefore it is calculated on the basis of height. देखिए formula shta cha मुंगता time period of vibration structure आकर या height से multiply करूँ h to the power 3/4, right? अब हम स्टडी को इंशाल्लाह खुदे दो में कम time period of vibration कम dependency दे यहाँ the value of R बन दे साथ सो यो structure दे है कि less columns है. Again I'll try to explain it. और यो bulk structure दे है कि less columns है, दोनों की equal भी. खुदे यो structure number 1 के less columns कम दी the size या dimension कम दे यहाँ 12 inches by 12 inches. Two less columns कम दी foot by foot. All the 10 columns are 12 by 12 inches, while in the second structure all the 10 columns are 24 by 24 inches, 2 by 2 foot columns. Number of columns are same, 10, but one structure is having slender columns, very narrow columns. The other structure is having very stiff columns, size bhi hat de. Now de wajana the vibration chikam de, the 2 by 2 foot wala column wala structure chikam de, it will not allow the vibration for greater time. All the column no predi, column mazboot di. De मुकाबला के यो कॉलम से कमजोरी है स्ट्रक्चर के कॉलम्स डन रही आहा चला खुंदे के आप करा 5 स्केल नॉय के वाइब्रेशन ऑफ सारी की न के दिशा के कॉलम क्रैक माच देख दे स्ट्रक्चर था चेक फुट बाय फुट कॉलम देता मुका में स्ट्रक्चर वो अकल जब के ठेकेदार स्ट्रक्चर कॉन्ट्रैक्टर स्ट्रक्चर जिनन से पाकिस्तान के ढेर ज्यादा अहम दे चे कॉन्ट्रैक्टर और बिल्डर जानता इंजीनियर वही और यो तासो होता हुए यो दो स्टोरी स्ट्रक्चर माता डिजाइन की. So he will put the size of the column foot by foot. And when we call him to design to construct a 20-story structure, shell chata, आए कि मैं column size बस foot by foot. So that stupid person which is called contractor nowadays in our society, he is the person which is putting the whole society on a risk. These are the blunders which is done by these contractors which call themselves as category D contractor or category E contractor or the other project. But it's the boy. Private Pakistan Almiyada, we are underdeveloped country, we are living in a country which is not having a governing agencies to cater this type of people. Check and balance nishta. Especially tasu kapal kurnu ogore. I am giving the practical examples. Tasu kapal kurnu ogore. If you construct a residence recommended by a contractor, tasu contractor to which amata kor jod ki, no ha koshish badai. Zyad diwaruna pake 4.5 inch. Half brick wall. Half brick wall hai chahe ki 4.5 inch diwar brick yes to vertical brick wall is showing a thickness 4.5 inch. Why he is going for 4.5 inch wall? Deke mantak da de chahe labor देखे बाप 1.5% 4.5 इंच दीवार बहुचत तासो यो लेबर चिना है दीवार सब लस पुटा तरह सही नो इट विल टेक 4 days फॉर एग्जांपल ओहा का दालस पुटा पूरे यो दीवार उचतई 4.5 इंच ब्रिक वर्क के आया तम हाफ ब्रिक वॉल वायु आहा बदे निमरस के बहुचत की नो फायदा कम हो के देख कंट्रैक्टर दा दे हाफ ब्रिक वर्क एंड ही विल मिसगाइड यू जे सासो द खखते चिकम दे दा ना इंच दीवार के डबल लगी दो चंद लगी और 4.5 इंच दीवार के खखते ढेर ज्यादा बचत दे सीमेंट बचत दे टाइम बचत दे दा दे आ दे no ha client misguide ki owner misguide ki tasu pake misguide. As an engineer, remember, never allow a single wall of 4.5 inch in your house because it is the most weak type of roller support. Brick wall ke yo problem da de roller support de da hinge ne de da chila hunde ke 4 skills zala rashi de ke tool cracks barash और चिदा पके लाता सो 4.5 इंच के जोड़ के नो दा रोलर सपोर्ट हमने खिलाएगी देता मुंगा यू प्लास्टिक दीवार दा यो लत सरमाती नो दा जलजला जबरदस्त यो तासो पे बारा लंडर जोड़ के हां स्लैब लोड पे वाचवे नो डेड लोड चिदोना प्रोती दीवार च हमने हाथ से शू तासो पिछो दा पासा पूरा हरे है राइट. So why I'm quoting these examples to you to alert to keep you alert to keep you attentive. Whenever you visit somewhere, you stand somewhere and you see a contractor constructing a house with a 4.5 inch wall, you should punish that person. You should hit that man. The engineering codes के allowed ना दिशे तासु यो कोड के 4.5 इंच दीवार वर्क के वाल बता सासु फल करूँ ना टोल दीवार में 4.5 इंच में यल्ला देखे. So I am alarming you that you should be very much active because you are learning the designing of earthquake. So if you do not know the basics of design, there is no need to learn these equations and to get CGPAs and to get. There are so many students, those which have graduated and they are involved in some offices, they are involved in government agencies, right? So I've seen them, even the engineers from UT. I have seen them, they have no idea whatsoever what is the role of 9-inch brick wall in a house and what is the role of 4.5-inch brick wall. They even don't know these things, so how can you design a structure? Right? So 4.5-inch wall is only a partition wall which can maximum be used in a residence when you are actually, for example, the wall of a bathroom, the partition wall of a bathroom and a dress, something like this, the partition wall of a kitchen. Load otherwise never allow a 4.5-inch brick work in any residence in your lifetime. When you come to framing structures, no R value come de, the dependent de, by that thing is called the type of structure, right? Let me come to this let me come to this, right? Don't worry. I think we have studied these 3 types at a glance when we were studying the subject of steel structures, if you remember. So these were the structures like SMRF, special moment resisting frames, IMRF, intermediate moment resisting frames, OMRF, ordinary moment resisting frames. F frames. So it means that we are discussing the framing structures now. They give residential houses, units, danishta bage. Amar tariqe se to explain kuch residences ke ya room ke the most important thing is the brickwork and the brick wall thickness. Okay. When we talk about the frames, it means those structures which contain columns, beams, all this stuff. Brickwork load bearing walls nishta, partition walls itu. No those framing structure ke tasu partition walls 4.5 inch ke jodule is problem nishta. Right? Only the outer walls need to be constructed with 9 inch. However, if the height of the wall is too much, if its length is too much, then you should be going with the 9 inch wall in even framing structures. अलबत्ता याद ला रही framing structures के पर दीवार वजन नहीं. In framing structures, the walls can be removed anytime because these are not the load bearing elements. These are called the non-structural components. No का दीवार के चलते crack अमराश यो हा framing structure framing like commercial building दे, hospital दे, SAS university दे, चाहे कि यार के कॉलम SAS structure तो देखे दीवार के crack राम it is not called a structural crack. It will be a non-structural crack, but it needs to be repaired as well. But anyhow, most of framing structure के साथ total frames the columns, the beams. How can you upgrade a structure? How can you, I would say, grade a structure for an earthquake, right? Based on moment resistant capacity, the earthquake structures are called as most resistive when you develop these as SMRF, and these are called less resistive when you develop these as OMRF. Ordinary moment resisting frame. Ordinary. Sada. What does it mean? It means that your structure can behave well under small magnitude of load or under small intensity of load, but it will not behave well when the intensity is huge. Practical example से सासो ये structure का पेशवर के जुड़ी ना zone 2 भी ले और का ये उनका का structure तासो चतराल के जुड़ी या zone 4 दे तो क्या भी खबर आपको ना zone 4 is high alert zone for earthquake, so your OMR structure will never be able to behave well in zone 4, but it can behave comparatively well in Peshawar. So it is indirectly, I would say, this type of structure is allowed in zone in moderate seismic zone structures, but these are not allowed in high seismic zone or red seismic zone. The R value chikam de mata, so the R value discuss code. Coming back to this value of R. For OMRF structures, the value of R is normally taken as 4.5. Sumraji, 4.5. The R value from the table is taken as 4.5 when it is designed as ordinary moment resisting frame. Was the ordinary moment resisting frame design cases involved with our next lecture to discuss. So, no daya sadi next lecture taso para there is important de kata so the earthquake design parameters or design codes is the core body, right? But remember this now, because in the coming class we will not discuss R in detail. We will discuss the design methods, how to get good R. Today I am discussing this R in detail. The R value is taken as 4.5 for OMRF. When your structure is designed as IMRF, so IMRF se tamai dam detail ke next lecture ke discuss kuch IMRF ta so single design correlation or OMRF or IMRF ke farak se ho R value kam de IMRF da para mu akhlu 5.5. Right? Remember this. The value of R is taken as 5.5 for intermediate moment resisting frame, and the high node of safety is achieved in SMRF structures, which are called special moment resisting framing structures, in which the value of R can be achieved up to 8.5, the maximum value, which is available in the table. And how to get this value in a structure, we'll learn it in the coming lecture when we discuss the SMRF in depth. चाहे कहता सो कॉलम सर बस कवे बीम सर बस कवे नोर पके structural elements पे ऐड कवे चिता सो structure convert करे from IMRF to SMRF, right? But this is an important parameter in the denominator. If you can achieve good number or good value of R, you can actually control this V. You can curtail this. Even seismic zone 4 के में सासो V बड़े कम पादिशी के सासो हार था उसका maximum मिला उसे ना सीखना. हम दा कार मुं practical को कम red zone के structure design को red zone के मुं R value दुमरा एक peak तो रसाउ चा value मुं दा पारा 10 शी चा V 10 दे लगा zone 2, हाँ लगा zone 2 है or 2B. No मुं structure दोनों safe को चा structure जैसे pro दे लगा seismic zone 2 के pro दे दा structure 4 के डो pro न दे सिंगा मुं करे दे dealing with this R and T interlinked with each other, right? Now this separate parameter which is in nominator, the nominator के देखा denominator के it is directly proportional to V, or V is directly proportional to W, I would say. It is called total load of the structure, which is the combination of dead load, live load, superimposed dead load, that whole देके ऐड की. तो देन अच्छी कम सा सो value मिलाएगी तास्ता कम value मिलाएगी. The value is so structure directly hit कहीं go again directly proportionally. So if a structure is having greater value of loads, it will be having greater value of earthquake force in it at the time of earthquake. How to control this V? You have to control this W. capital W by control kaway, the SAS structure by safety, or SAS value by control EV, right? Base share value will be in a controlled way, in a control zone. The W is controlled by reducing the value of SDL. If you remember, we have studied various types of static loads in the steel structure course. Now, I can loads we start to discuss for you: dead load, live load, or superimposed dead load. That's the yet. Dead load mung chukam de aye to iso ke tek simu bana yo tam moyu self weight or yo tam moyu superimposed dead load. The self weight ki chukam de a weight chika sa so the structural components weight. The slab, the beam, the column, the foundation, the structural components. They chukam total weight the item so self weight, or I would say effective dead load. Self weight is that type of dead load which is very, very important. It's effective. You cannot reduce it. It gives you the strength. For example, the structure of columns lere ke no dead load ho kam shi structure ba kamzor shi no self weight chikam de da important da manushya ko mole da rang sa so live load chikam de. It is dependent on the type of structure. Chahe core de ka, plaza da ka, yo hospital de ka, yo university da ka, yo college de ka, school de no aye sab so live load chikam de ho fix hi. You cannot say no, you cannot allow more than 100 students in a college or in a university or in a class, right? Just the para design da banaji structure like a university institution jodi ke de para chahe ka student na shi sabak hui kana. So you cannot control the live load, you cannot control the self weight. Naming sar sa pa de should dead load ke superimposed dead load SDL. So only a structure can be designed safe against the earthquake if you can control its SDL, superimposed dead load, which is part of this W. So W there shall judi ha they formula the empirical equation. Capital W is equal to D se the move self weight plus SD superimposed dead load plus L. No first or third it is not compromisable, but this middle value is need to be controlled all the time. Us SDL ta so pata se jodi ki steel structure ki study kari if you remember it. It is the load of flooring, the load of partition walls, the load of false ceiling, the load of mechanical devices, electrical installations, furniture, and door, windows, and all this stuff. That whole chicken is a SDL. The load de chaha is fayda na raka imung structure ke mata samak value. So if you can control this SDL, you can control this V. So even a structure with medium value of R, there R value pake nahi kana. Cost factor R can involve actually. When you get good value of R, you need to improve its structural members, steel, all this stuff. No, extra cost factors रहती है. वो कहता है medium R value achieve पे, right? But you can still minimize it to 0 with medium value of R if you can minimize this SDL in the W. Bas, this is the cream of designing the structure against the earthquake. You should actually control the SDL in this whole equation. No, zamung labelubab the outcome se should anan lecture in this whole empirical formula which gives you the total earthquake force at the time of earthquake in a structure. You can minimize it to 0 if you can control the SDL in this whole empirical equation. W के दरे किस्म लोड यहाँ D, L और SDL. SDL चे control को दा कता सो minimize को का 0 तेराविस तो ये close to 0. Your whole structure is designed against the earthquake. चरम बनने लगी, right? Nature cannot let this structure to fail until unless Allah Almighty allows it. Take sure. So therefore, it is very important. D W come the contributions. This is totally explained in 1630 article of the Seismic Codes of Pakistan that your total seismic load is the combination of self weight, superimposed dead load, and live load. Practically, practically, the SDL is taken 100% in the calculation of W. 100% मतलब से no इस तरह structure की the floor देखा, partition walls देखा, wood work देखा, electrical work देखा, plumbing work देखा, furniture देखा, so that whole था so 100% load बा calculate के और देश के मैं watch देता हूँ वो 100% right. न देखे SDL 100% वालू dead load यानी self weight. So pillar बीमान चतुना staircases that whole the they told load calculate को 100% देखे आप. और live load से कम दे अहम 25 to 30% because all the time your live load is not 100%. चरता यो core the nucleus tanan incherta do tanan incherta dre by incherta. Let's say it's not fixed all the time. Darang yosta so institution de no, it is not always at peak. No, they keep your codes recommend 25 to 30% livelihood chaval, it is safe, right? So this is how this W is calculated, and it plays an important role to control this V value, which is called the total earthquake force generated due to the earthquake waves at the time of earthquake in a structure, right? I hope I've explained this empirical equation, which is very important for you because this will help you in designing a structure as OMRF, IMRF and SMRF. We'll discuss in the coming lecture as well. Now going further, how to calculate this? First, to calculate this V, you have to find the specific site details. Site detail that so the gore seismic map by study kawe chada, for example, dir ke structure jodogi taso dir study ke dir seismic zone of Pakistan ke charta lai kai the seismic zone sa de the terrain sa de fault line of fasla sumna de 50 km range ke de 100 km that will show sakela vi site specific details. Once this is determined and you have taken the required information, then you have to determine the seismic coefficients from the codes based on this information. That's a CVCA variable chat. Then you will have to determine the class of structure. The class 1 ke, class 2 ke, class 3 ke like the important similar to the structure. Singamata explain your core, your plaza, your market, your hospital, the education, the institution, the so I value ba codes number select. Then the value of R, so the structure was single behave for either by IMRF, the SMRF, the OMRF. Based on that, we will take the value of R from the codes again. And then time period of vibration is interlinked with this thing, and the height of the structure also calculated through a formula discussed. And then finally you get the value of V, but this V is determined after you totally satisfy yourself and get the lump sum value of capital W, right? This W. Shahzad जुड़ी live load, self weight or superimposed dead load. So then the V is calculated, and then V is then distributed over the structural joints, floor wise, story wise, the available procedure. This is the V chikam de biamu. Structure wise, the joints single convert to the para joint dressing and proof the design ke razi. Ha this slide ke fir see. We are looking actually on a UBC 97 or BCPS P07 load combination. UBC the combination so BCPS P07 can include the dead load the para modification factor 1.4, live load the live load chip again be 1.4, dead the para 1.7, load increasing factor live load the para the UBC 97 ke di ACI ke da shuna dear zyad kam di the American courts in the devajana mung suggest ho. Therefore your BCPS P07 is not generated from ACI, it is generated from UBC 97 to improve our load resistance performance of structure against the loads, because in Pakistan, which is an underdeveloped country, there is no proper check on the structures when these are constructed. That's Pakistan ke research jodi you dukan jodi idre ka lo pore dukan hi byapa ke market shi byapa ke godam shi byapa ke hotel shi byapa ke hospital shi byapa ke dispensary shi jiyo shani chali bal tayari, and there is no rule in the government sectors or departments to control that thing, to not allow the structure to be used for different purposes. But we cannot control it here in Pakistan. Naksha manzoor ki as a residence pake Joshi market, Naksha manzoor ki as a market pake hospital jodi, Naksha manzoor ki as a hospital pake flats jodi. Now they were so the fluctuation in the dead load and live load there zyad de. Now they were the experts have suggested that Pakistan building codes should have higher safety factors or load increasing factors. Now ACI ke dashe tumra nishta ACI ke dead load para sumra de 1.2 dalta ke sharia 4 de al the live load 1.6 1.7 de dalta devajana the earthquake the notion chikam devajana we are supposed to use the UBC 97 version or the codes load combinations. So the same load combinations are plotted in the Pakistan building codes, right? These are the structural reduction factors for flexural elements like beams, for shear elements, beams and columns, for tides, shear designing of columns, for spirals, all these are the strength reduction factors when you design various elements of a structure for earthquake. These are just the representation of some of the codes, right, that we are using in the design of earthquake. Now BCPS P07 chapter 5 7 ke the UBC two load combinations the earthquake resistance reduction factor zikr shtada chapter 7 of BCP and chapter 5, huh? But anyhow, when we use the design codes, we have to see, we should have a grip on all the design code structures of Pakistan Building Code. The YIC is not recommended. YIC 318 is not good for us because it is having very small load combinations. The load modification factors are not that much suitable for Pakistan, right? मुझे वजह ना दामूंगा कोशिश करोगे चिदा दहरनी ACI पजेमू UBC the preference work हो. Okay, going back, these are the load combinations for earthquake, light load, dead load in advance. The Pakistan Building Codes के दायो slide में से include करे दे what these codes are, how these behave, something like this. But we'll see it when we are doing the practical design of slabs and various beams and columns. Inshallah. Now the outcome of today's lecture is that, remember, these are the guidelines for the designers, but I am presenting it to you so that you may also be able to learn it, right? Remember, always remember, when you design a structure for earthquake, this is the conclusion of the softwares, but the manual analysis also gives us these conclusions. The lower story of a structure, you so 5-story structure, they can 4-story, 3-story, multi-story. The lower story, positive end moments in beams may become significant in higher seismic zones. Then it means that your beams are critical at joints in lower parts or lower stories of the structure when there is an earthquake. So earthquake time ke the chat biman chikam di the joints ke der zyad critically the joints failure ratle shi the joint nahi kada beam mughal beam sara ya karam sara use ki ge tam joints hoye bana. So these joints may show failure at the time of earthquake, the time of earthquake these may show failure, especially in which place? In the lower stories. Now you need to be very much careful in designing the joints of beams and columns and beams in lower stories. This is a conclusion, recommendation I would say. The guideline of designing of earthquake. The guidelines you told me, second guideline. There is no significant change in beam mid-span positive movement. That is very important. There halkaman gari person poegi और ज़लज़ले पर डिज़ाइन का स्पेशली कॉन्ट्रैक्टर हजरत वो इधर ज़लज़ला प्रूफ बिल्डिंग भी नौचत बीमान चिकम दिया है कि कई लस दो सरी पके लंग मंस के लगी नौदे पके शपकवाच कबरम दो सरी ले दिए पके शपकवाच नियो बीम के कपाउटन सरी ले दिए पके 1 टन सरी इस्तेमाल की चिता पोस्ट नो के दवाले विदावे मजबूत करे दे ज़लज़ले दा पर. Again, I'll quote a practical example here. I have visited a structure. There is a residential structure hujra dalta pehor ke jod, and the contractor sahab chekam de what he has done. He has veranda as well as put up veranda. He has applied number 6 bars in the slab of veranda, and he has used almost 7 tons of steel in that veranda, and he has misguided the owner. चिदा मुदे वजन को लगी च देश रस्ता सो दा वरंडा चकम दे जलजला के बस बराबर तन सो न वजन चाच इसम ने की उल्टा कार्य करे और डेड लोड पे दोना सेवा को ओवर इन्फोर्स को ओवर इन्फोर्समेंट दा वजन रस्ता सो स्टील चकम दे फेलड़ो न फेल की और कंक्रीट चकम दे हा दे स्टील जरा समय नो रिंद दा फेल आज फेल ची न देश रसे की द होल स्ट्रक्चर विल फेल न उमदा कारो शु सिंगा चाहो है कि ओवर स्टीलिंग ओशु ओवर स्टीलिंग चकम दे हा रिजल्ट that resulted in creating cracks in all the slab of veranda. Dashe da वही लगी है ठीक शू earthquake designing के दा बीमान सरिये इस कार निश्ता नो दे मतलब दाशु जैसा सो बीम का जोन 4 के जोड़ेगी ये स्ट्रक्चर का जोन 4 के जोड़ेगी का जोन 3 के जोड़ेगी का जोन 2 के जोड़ेगी का जोन 1 के जोड़ेगी याद रही the beam steel सरा दे इस कार निश्ता the beam steel is only to deal with static loads earthquake कोई dynamic force है ना so